So guys, in this video, I'll be explaining the 10 projectile. I will explain the meaning of motion. I will also explain the meaning of the time of flight, maximum height, and the range. I will explain all the hidden details that involve in solving projectile questions. Alright? So, but I'll first of all start with the motion. I will also state the three equations of motion. I will state the the formulas and what the laws governing those equations, and I will explain everything concerning motion. So I'll also explain how uh, projectile involve the two components of velocities, and I'll also explain how the horizontal component of velocity is constant throughout the motion, but the one of vertical component varies or changes with time. Okay, so if you're here, you're not in the wrong place at all. Teachers, students, and undergraduate students who are struggling with physics and motion generally, if you're here, you are not in the wrong place. So guys, let's start. What is motion? Let's first of all understand the meaning of motion. Motion is a movement of an object from one point to another. All right. So there are some things that causes motion, things like force. Okay. If not, if an object is sitting or it resting, it will always remain in that position. If nothing causes it to change its motion or causes it to move from one point to another. Assuming for the case you allow a textbook to lie horizontal at rest on a table, if nothing touches this textbook, it will remain there forever. But if something or an external force try to move that textbook, so it will now shift its position from where it resting to another position. So that will become the movement, and that will become motion. So in motion, there are some things that you need to understand, things like displacement, acceleration, velocity, and speed. So what is displacement? Displacement here is the distance traveled in a specified direction. So what is now velocity? Velocity is the change of what? Is the change of displacement with time. Okay, by the time you're changing your displacement, then with time that becomes velocity. All right, so mathematically velocity is equal to uh, displacement all over time taken, but in physics we use s. So displacement all over time taken gives us velocity. All right, then again, what is acceleration? Acceleration is a change of velocity with time. So we have that uh, velocity, sorry, acceleration A, we use small a to stand for acceleration, is equal to dv all over dt. Okay, this is the same thing as v minus u all over t, whereas v is a final velocity, then u is the initial velocity. Okay, so guys, since we have understood the 10 velocity, displacement, acceleration, let's now go back to projectile. Let's take for example, if assuming this is a tree, let me draw a tree for you here. Assuming you have a tree, oh, oh my bad, this marker. Assuming you have a tree like this, okay, you have a tree like this, and a, bear is sitting here, then there is somebody standing here, right, holding catapult. Okay, so now if this person release a stone from that catapult to where this bird is perching on this tree here, okay, you know, this stone that has been released from his hand will travel and then return back to the ground. Okay, so now again, let's say for example you throw a tennis ball and now landed on the wall. It hits the wall, then return back to the ground. You hit it, then back to the ground is another kind of projectile. Or assuming you fired a gun, if a bullet released or fired from a gun, it's traveled, assuming you use a gun to target somebody or target an animal. So that bullet will travel and return back to the ground. These are the kinds of bodies or objects undergoing projectile motions. Okay, so now what is the term projectile? A projectile is an object that has been launched into the air and moved freely into the air and has been influenced by the gravitational force. Okay, an object that is released or an object that is launched into the air and is moved freely and return back to the ground. So now if this object is moving, it moves in a parabolic manner. What do I mean by parabola? Let's see a curve. Okay, a parabola means a curve. All right, something that assuming you launch, this is where you're standing and you launch something at a particular angle and it's now returned back to the ground. This is the part of a projectile, and this part is what I call parabola parabola okay, or parabolic. All right, so this is in form of a parabolic uh, form. So the parts taken by a projectile is called a trajectory. All right, it's called a trajectory, and this trajectory part is in form of parabola. That is what we have here. Okay, this is what we have here. You launch something at a particular angle. All right, you stand and you launch something at a particular angle theta. You know, at the point of projection, this object will now take two components of velocity, all right, the horizontal and the vertical component of velocity. All right, so if you launch this object that you have launched into the air and you allow it to move freely, that is what we call projectile. So projectile is an object that is launched into the air and is allowed to move freely and then return back to the ground. Okay, so what are the examples of projectile? A bullet that has been fired from a gun, a stone released from a catapult, a person doing high jump, an athletic doing a high jump, or a tennis ball uh, throw from a wall and return back. These are the things, these are the objects that these are the projectile. All right, so all those objects that undergoes this motion, okay, all those objects are called projectile. So now you cannot understand the term projectile without knowing the three equations of motion. All right, So before you understand the term projectile, you should be able to understand the three equations of motion. So let's state those three equations of motion, okay? And then you still need to understand the term free fall, okay? So let's take these three equations of motion. The first equation of motion, which states that V is equal to U minus AT, okay? And the second one, S is equal to UT plus or minus, sorry, yes, plus or minus. Let's call it plus or minus, okay? So GT squared. Then the third one is V squared is equal to U squared plus or minus 2AS. Okay, so you can use this formula when you know when you have time, you know acceleration, you know the initial velocity. Okay, but in a situation where you don't have, uh, here is to find the distance. Okay, here to find another final velocity. So you understanding, sorry, this is small a, all right? So for you to understanding these three equations of motion will help you in understanding the projectile. But what of the case where these three equations here are used for body moving in a straight line on land, not when a body is going upward? So what is the case where the body is moving upward? All right, so if the body is moving upward, we now have that V is equal to U plus or minus GT, that is the acceleration on land has converted to acceleration due to gravity, the G, right? Then you will now have S here. S now will become H because when you're going upward, your distance be converted to H, become height, all right? So you now have UT plus or minus GT squared. Then you have V squared is equal to U squared plus or minus 2GH because the distance has converted to height. Okay, so when you understand these three equations of motion, it will be easier for you to understand the three to understand projectile. So now let's now understand the two components of velocity that involved in projectile, because when you launch an object into the air, at the point of launching that object, this object takes two components of velocity, and this is the diagram we have here. Okay, this is the diagram we have here. When you launch an object into the air, first of all, at the point of launching that object, it takes an initial velocity. So that initial velocity, it will move in the horizontal direction as well, and also in a vertical, it will have a vertical component of velocity and a horizontal component of velocity. Okay, so at each point, you will see here you have until you reach the maximum height. At the maximum height, the velocity is equal to 0. Okay, because when you launch, if you throw this marker upward, if you throw it up, you know this marker will continue to go up until the velocity at the initial velocity which you launch this marker up, it will continue with it, and it will continue to reduce until it attain a maximum height. So at that maximum height, you know, at the maximum height, the final velocity will be 0. That is why it will not continue to move. Then it will now do what? And start moving back to the ground. So at the maximum height, the final velocity is equal to 0. Okay, at the maximum height, the final velocity is equal to 0. All right, so now this projectile, we have two components of velocity in the horizontal and in the vertical. So these are the this is what you have. So in the horizontal component of velocity, you have that Vx will be equal to u cos theta. That is, if you want to find this angle here with respect to uh, uh, adjacent, which means you are going to have u cos theta. Then if you want to take it, assuming this has formed an angle, okay, this has formed an angle, and you know the longest side of any angle is always hypotenuse. So this will become the adjacent to this angle, and this will be the opposite to this angle. So, and you want to find the value of this theta here, which means the vertical, which is Vy, the vertical component of velocity will be u sine theta. Okay, so these are the two components of velocity you have in the vertical and you have in the horizontal. If you launch this object, it will land at some point, it will reach a maximum height. So this is the maximum height. So here, the final velocity at the maximum height, the final velocity is equal to 0. So when it reached the maximum height, it now return back to the ground and hits the projection plane again. This is the projection plane. So it travel, it attain a maximum height and then return back to the ground and hit the projection plane again. So at this point, the vertical, at the point of hitting the projection plane again, there will be no height. Okay, so there will be no height, so the height will be equal to 0, right? So now let's understand the 10 let's understand the time of flight, the maximum height and the range. But before we understand, when you throw something upward into the sky and it's going up, you know that object is going against the force of gravity. You understand? So when it's going against the force of gravity, when an object is going upward, the equations of motion take negative signs. Okay, when object is going upward, these are the formula. This v is equal to u minus gt, s is equal to ut minus half of gt squared. V squared is equal to u squared minus 2gh. That is, when an object is launched, is going upward into the air, the equations of motion take minus sign. But in a situation where the object is coming back, the equations of motion takes positive sign. So keep those things at the back of your mind. When you launch something going upward, it is going against the force of gravity, the gravitational force. So the equations of motion take negative sign. But in a situation where the object is coming down, maybe you stand at some height, you stand somewhere here, assuming this is a building, okay, this is a building, and somebody release something downward, that object that is coming downward, the equations of motion take positive sign. All right, it takes positive sign. So but if you launch upward, it takes minus sign. So take those things at the back of your mind. Okay, and again I explained that when you launch a projectile, it has two components of velocity: the vertical, which is uh, Vy is equal to u cos theta sine theta, and Vx is the horizontal component. a body undergoing projectile motion, the horizontal component of velocity is constant. Why? It is because there is no acceleration in the horizontal. uh, for body undergoing projectile motion, there is no force, there is no acceleration in the horizontal component of in the horizontal direction, but there is a force. When something is going up, there is a gravitational force that is trying to pull it, so there is acceleration in the vertical direction, but there is no acceleration in the horizontal direction, which means the horizontal component of velocity is constant, is always constant at the initial velocity of that object. So there is no changes in the horizontal direction, but there is changes in the vertical direction. Okay, so now let's uh, understand the 10 time of flight, the maximum height, and the maximum height, the range. Okay, so what is now uh time of flight? What is now time of flight? The time of flight, okay, the time of flight is a time taken for a projectile to complete uh uh it is a time taken for a projectile to move from the point at which it has been projected to the point the projectile hits the projection plane again. That is the point at which the projectile has been projected till the point it has the projectile hits the projection plane again. That is the total time of flight. Okay, so the time of flight is the time taken for a projectile to complete its motion, to complete. Okay, so at the point of projection and the point at hit is the time of flight. So now let's understand. We know that at the at the maximum height, velocity, final velocity. So why using this equation here? Uh, we're using sine theta, assuming you this has been projected at a particular angle. So which means it will take uh when it's going up in the vertical direction, it will take sine theta, then minus gt, all right, because it's going up. That is why it's having minus sign. So but at the maximum height, v, at the maximum height, v is equal to 0. So which means we now have 0 is equal to u sine theta minus gt, all right. So here you want to find t. You take gt, you take uh gt to this side, then you have u sine theta. So you divide both sides by g. Okay, g will cancel g, and t will be equal to u sine theta all over g. Okay, but remember, this is just the time taken to reach a maximum height. Okay, so now the time of flight is the time taken for projectile to travel a complete path. All right, so this time we find here is the time, the small time, okay, is the time taken to attain the maximum height. And the time, so if an object attain the maximum height, is the same time it will take it to return back to the ground. So the time of flight, capital T, is equal to, okay, is equal to 2 times small t. But we know that small t is given as this, so which means time of flight will be equal to 2u sine theta all over g. So this is the formula for finding the time of flight. Okay, so let's now drive the formula and know the meaning of the maximum height. What is now maximum height? Maximum height is the highest height attained by an object or by a projectile. The highest, maximum height, that is the highest height attained by a projectile before returning back to the ground. When you throw something up, it will continue to go until when the final velocity is zero. At that point, that is a maximum, that is the highest distance. It now returns back to the ground. So the maximum height is the height attained by a projectile, the highest height attained by a projectile before returning back to the ground. So how are we going to know, how are we going to have the gravity for maximum height? Okay, so in finding the maximum height, remember at the maximum height the final velocity is equal to zero. Okay, so this will be equal to u squared, or the horizontal, the vertical component of velocity will have u sine theta. So everything is going to be what? Squared minus 2gh. Okay, so we now have that. With this, we now want to make h, and still remember that at the maximum height, at the maximum height, h is equal to small h. That is, at the maximum height, the maximum height is equal to the height. Okay, so which means you want to make h the subject. You now have 2gh is equal to u squared sine squared, okay, sine squared all over. So now want to divide both sides by 2g. 2g will cancel 2g. H will be equal to u squared sine squared theta all over 2g. But small h is equal to capital H, so capital H now will be equal to u squared sine squared theta all over 2g. So this is the formula for calculating the maximum height. So now let's talk about the range. What is range? Range, okay, in the other hand, is a total distance, covered by a projectile. That is at the point of projection and where the projectile hits the projection plane. The total distance covered or traveled by a body undergoing projectile motion. So at this point to this point, that is the range. The total distance traveled, the point of projection and where the projectile hits the projection plane again is the term range. So from here to here we give you the range. Right? So let's now understand the term range. So range is the time of flight, that is the time of flight times the horizontal component of velocity. So let's use a formula to drive it out. Okay, so now range r is equal to the horizontal component of velocity, which is u cos theta times time of flight. Okay, capital T stands for time of flight. Know that time of flight is equal to 2 u sine theta all over g. Okay, so let's put it back. We have that range is equal to u cos theta times 2 u sine theta all over g. Okay, so with here we know that 2 cos theta sine theta is equal to sine 2 theta. Okay, so we can remove this and put that range is equal to u, because u times u, that will give us u squared, right? U here times u here will give us u squared. So here u times u from the formula will give us u squared, right? So this is the formula for calculating range. Okay, so guys, please turn on the notification bell and subscribe to my channel so that you can follow more of this. Bye.